Hello, College Algebra, and welcome to 6.2. This is very similar to your last section. The only thing different here is that you're going to get weird solutions. So before you got x equals a number, y, and z. They all had variables, right? And this one, they're going to be something weird, like you're going to get it 0 equals 0. Remember those are infinite solutions, or 0 equals 5, which was no solution. And that's what is going to happen here, because we can do the same thing as we did before, just in the Gauss-Jordan method. All right, let's go. All right, so this one here is a no solution, since it tells you that on the top. So we do the same thing we've done before, and we write them down. So we take the 1, -2, -1, -5, and we create our matrix. 2, -3, -1, 0, 3, -4, -1, 1. Okay, the 1 is already here for me, which is what we want. So then we have to get rid of the 2. So I multiplied the top row by -2, and I added it down. So -2, 4, 2, 10. Added it down, and we got the 0, the 1, and the 10. The first and the last row stayed the same. So now we've got our second matrix. Okay, now we need to get rid of this 3 because we got the 0 here and the 1 here. So to get rid of the 3, I'm looking at this column right here. So I could take the 1 times the -3 to get rid of the 3. So we're going to multiply the first row by -3 and add it down. So we got -3, 6, 3, 15. We're going to add down. So we're going to get 0. 6 and -4 is 2. 3 and -1 is 2. 15 and 1 is 16. Your row 1 and 2 stayed the same. So nothing different. Doesn't look weird too far, right? And you do the exact same step. There's nothing different here. So now that I got this to a 1 and this to a 0, it's time to change this guy to a 0. So I got to take my second row times -2 and add him down. But this time when we do this, we get a 0 and a 0 and then a -4. This is not possible because that means 0x's plus 0y's plus 0z's equals -4, or 0 equals -4. This is not possible, so there's no solution to these three equations. They do not intersect anywhere, those three lines. All right, now let's look at another one. This one's infinite solutions. There's a lot more work to these, but we do start them the exact same way. So we go 1, -2, -1, 5, 2, -5, 3, 6, 1, -3, 4, 1. Again, the same thing is true. We need a 1 here, which we want. Now we want to change this to a 0. And I always seem to start the first one and multiply down to get rid of this. So this time I'm going to start at the bottom just so that you know that that can happen and that you look for different patterns. So here I'm going to multiply the denominator by -2 and, or not the denominator, the third row by -2 and add up. So -2, 6, -8, -2. Okay, now let's add that up. Remember your first row does not change. 1, -2, -1, 5. -2 and 2 is 0. 6 and -5 is 1. -8 and 3 is -5. -2 and 6 is 4. Bottom row does not change. Okay. Now we're doing fairly well here. We've got our 1, our 0, and our 1. So 2 of them changed that time for me, which was nice. So now we got to get this guy to a 0. So we're going to multiply the top row by -1. Different color here. And then we're going to add it down. So nothing new, right? So -1, 2, 1, -5. So now remember, the top row does not change. 1, -2, -1, 5. Middle row does not change. Last row changes. -1 plus 1 is 0. 2 plus -3 is -1. 1 plus 4 is 5. Negative 5 plus 1 is negative 4. Did I forget to add here? Oh, I did. Anybody else catch that? I hope you did. Negative 2 plus 6 is 4. Correct. So let's change that. All right. So now when we're going to go through here, I need to get this guy to a 0. Well, all I have to do is add these two up. So now when I add those two rows, and remember the first row does not change. The second row does not change. The third row now becomes 0, 0, 0, 0. When you get all four zeros on the bottom, this means there is infinite solutions. The problem with this is that you can't just say there's infinite solutions. You have to show me how they're related. So our new matrix that we have right now is 1, negative 2, negative 1, 5, 0, 1, negative 5, 4. All right, because the bottom row is zeros. So this means that this is x minus 2y minus z equals 5. Then this one is y minus 5z equals 4. Okay, we have to solve these in terms of a variable. It doesn't even matter what variable we pick. But when I look here, this bottom row is very easy to solve for y. So I let y, and I get y by itself, which means y equals 5z plus 4. Okay, I solved y in terms of z. So that means z is what I'm looking for. So it's my unknown. No matter what z is, I pick a number, and then I can tell you what y and x are. So now y is 5z plus 4. But now we have to figure out what x is in terms of z. So we take this equation, I take the y out, and I substitute in the 5z plus 4, what y is equal to. And now we just solve for x. So we distribute, combine our like terms, and then I'm going to put the 8 and the 11z to the other side. So x equals 11z plus 13. These are my infinite solutions. So this means if I pick a number for z, I can tell you what x and y are. So I have solved for everybody in terms of z. There's infinite solutions because I can pick infinite number of z's. I hope that helps. All right. A lot of times they try to help you and have most of the work done for you, which is possible, but we have to be careful. If you look here, there's only 2 equations, and the third one's gone already. All right, since the third one is gone, we don't have as much work to do, but it is the ugly work. So the first thing we have to do is get rid of a variable. Or we have to get 1, 0. So I've got 1, 2, 3, 70, and 1, 1, 1, 60. Well, I just have to get a 0 anywhere. It doesn't matter where, as long as I can get it down to 1. So I'm just going to take this guy times negative 1 and add it down. So negative 1, negative 2, negative 3, negative 70. Add down. Remember, the first row does not change. My second row is now 0, negative 1, negative 2, negative 10. I don't like all those negatives, so I'm just going to multiply by a negative 1. And those are my new equations. Now I use what I just learned, and I find the infinite solutions. So we have x plus 2y plus 3z equals 70. And we have y see if we can write a z correctly. How about that? Y plus 2z equals 10. All right, so again, it's easiest to solve for y. So y equals minus 2z plus 10. So now I know I'm in terms of z. So far, I know the z, and I know what y is. Now we got to find x. So I'm going to take this and substitute it in up here. I'm going to take x plus 2 times what z is equal to. Negative 2z plus 10 plus 3z equals 70. So now let's solve that. X minus 4z plus 20 plus 3z equals 70. Combine my like terms. X minus z plus 20 equals 70. Bring them over to the other side. So x equals z plus 50. So now x is z plus 50. And that is how my 3 points are related. Okay, I hope you understood. Make sure you post questions if you have any, and good luck on your homework.